Good morning, everyone. It's my great pleasure to invite you all for this session, Scientometric Indicators and Citation Databases. So particularly, I just want to say a few words about this webinar, Bibliometrics and Scientometrics. There are so many tools are available right now to analyze and to do perform a different kind of analysis like bibliometrics and scientometrics. But the session is going to explore you what are the basic scientometric indicators and bibliometric indicators are available and how you are going to perform those research by using several tools which are all available at free of cost. And this session is basically, it is a brainstorming session about scientometric indicators. You are going to explore what are the basic tools you can apply for perform scientometric analysis. So with this, we will go for the session. So this is the overall outline we are going to discuss about the scientometric and bibliometric analysis. So what are the bibliometric indicators and scientometric indicators, and what's the difference between scientometric indicators and derived indicators, and what are the bibliographic databases which we are going to discuss about, basic scientometric indices, and you should know some basic parameter like journal impact factor, journal citation report, and SciMago journal ranking and all. Site-score also are going to explore, and new scientometric tools and indices which we are going to cover in this session. And this is the overall overview about different kinds of metrics what we perform in the field of library information science. Like it starts from bibliometrics. Actually, if we talk about metrics, it starts from bibliometrics and bibliometrics, scientometrics, informatics, cybermetrics, and webometrics. This is what this picture which depicts about. And this is the overall timeline of different kinds of metrics which involved in the field of library information science. So for the overview, I just want to explain you here. We have started different kinds of metrics from 1926. From 1926 onwards, we have started from load cost law, bibliometrics tool, which we are going to apply for bibliometrics analysis. Like from starting from load cost law to Bradford's law, now we are using different kinds of analysis like Almain investment, webometrics, covert analysis. There are so many tools which we are going to apply and which are going to seen in the forthcoming sessions by applying the basic formulas for each and every tool anyway. And these are the classic metrics. What are all classic metrics as you are aware? Bibliometrics, scientometrics, informatics, or unique type of empirical research method, first of all, which are developed by library information science. And bibliometric basically utilizes quantitative analysis, statistics, and data visualization to investigate patterns like, so what are the different examples for which we can apply bibliometric analysis like references, citation, authors, journals, institution, words, keywords, classification codes, etc., which are purely related to library information science. And this is the basic definition normally people used to give. Bibliometrics literally means book measurement, but the term it's used about all kinds of documents. It is not only applicable for journals, but also for any conference proceeding on any dominant kind of document can be applied for this, which is measure not only physical properties of documents, but statistical pattern in variables such as authorship, sources, subjects, geographical origins, and citations, etc. It is defined as a study of quantitative aspect of production and dissemination and use of recorded information. This is what mentioned normally by, it is a given definition by Alan Pritchard. And what are the applications of bibliometrics? If you are doing any study, we should know for what application it is going to apply. So if you want to identify research trends and growth of knowledge and to estimate the comprehensiveness of secondary periodicals and library selection, reading policies, and to form information organization, information management, and to identify the users of different subjects, to identify the authorship and its trends in documents on various subjects, and to forecast past, present, and future publishing trends, and to predict the productivity of publishers, individual authors, organizations, and countries. For all these aspects, this bibliometrics is applied, and all other metrics like Scientometric, which covers science in general, not just publications, and Informametrics, it covers about all information objects. Webometrics or cybermetrics, totally related with web connections and manifestations, using bibliometric techniques to study the relationship or properties of different sides of web. Informametrics, it is again a study of quantitative aspect of information in any form or just records or bibliographies and in any social group, not just scientists. It incorporates, utilizes, and extends the many studies of the measurement of information that lie outside the boundaries of both bibliometric and scientometrics. Bibliometrics, from the word itself, it is very clear that it is totally going to be applied for the web resources, structures, and technologies on the web, drawing on bibliometric and scientometric methods like web page content, link structure, user information behavior like searching, browsing, etc., and search engine performance. Now we will come to the part like scientometrics. So scientometrics is a quantitative aspect of science as a discipline or economic activity. And it's a part of sociology of science it used to mention normally to take the policy making, whether we can go for that or not. It is to measure or analyze the science and technology and innovation. And majorly scientometrics, it's purely the measurement of scientific output and impact of scientific findings. We are going to use different kind of variables with respect to scientometric analysis. Like, for example, the first variable may be the author, like numbers in a subject field, institution or country, and growth or correlation with indicators, and productivity, it's about Lodkar's law, a collaboration, co-authorship associated, and networks like collaborated with other countries, that what kind of network has been established that can be studied, dynamics, productive life, epidemics, papers, authors in a subject, and mapping. So this kind of analysis can be done with a variable called by only author alone, and with the origin, rates of production, size, growth by country, by institution, or by language and subject. And the comparison can also be done between like correlation with economic and other indicators, and variable with the sources. So concentration most often on journals, growth dynamics in numbers like information explosion, exponential loss, time movements like life cycle, Hoff's life cycle, citation like that, and scatter like quantity, yield distribution like Bradford law can be applied, and various distributions by subject, language, and country. And by content also we are able to analyze by distribution of words as Zipf's law can be applied, words, phrases in various parts, subject analysis, classification, co-word analysis that can be done. And with the variable called citation, studied a lot, many pragmatic results by citation indexes like Web of Science, Scopus like that. Number of references in article, number of citations to articles, research front, citation classics, and bibliographic coupling. All these kinds of variables can be analyzed by using these tools. And the global research of science, it can be done in a different way called by international, by collaborative, by network, and interdisciplinary. All these analyses are possible by using this scientometric analysis. And why we need to study this? First of all, these are all the used for measuring the performance like trends, impact, and specialization, exclusively with international links, comparative positioning, national ranking, organizational or departmental strength and weaknesses, and to analyze the impact, diffusion, and to update collaborative trends. And you may have certain questions in your mind like, what is our research output? How are we trending over time? How do we compare to our peers? Where should we link to increase our edge? Who are the other top performers? Can we show value for the money? And where should we invest? What are all the up and coming fields? Why are we working at cutting edge? Are we hiring top performers? Is our research environment is world class? Where should we collaborate? For all these questions, there is a solution by using scientometric analysis. So here I'm going to explain you in a different dynamic, like what kind of metrics can be applied for what purpose. If you are working with a scientific production, like number of papers in a peer-reviewed journals. And what you are working with for production and weighted, number of papers weighted per capita or by investment level. For specialization, a measure of the research intensity of an entity in a given area relative to the reference entity in the same area, like citation strength. And relative impact, the expected impact based on the journals in which papers are published. And I will go with scientometric indicators, like there's a quantitative analysis in the field of science mapping to describe the patterns of publication within a given field of knowledge or body of literature. There are two main procedures. One is performance analysis and another one is science mapping. This performance analysis aims at evaluating group of scientific actors like country, university, department, researcher, and the impact of their activity on the basis of bibliographic data. And the science mapping aims at displaying the structured and dynamic aspect of scientific research. The science map is used to represent the cognitive structure of a research field. And other scientometric indicators such as journal impact factor, H index, level of non-citation, and page rank algorithm. These are all the other scientometric indicators. So tools which we are going to apply is like, several tools which we are going to apply, that can be, we are going to categorize in two different types, qualitative tools and quantitative tools. If we talk about qualitative analysis of scientometrics, then we can talk about citation mapping, visualization, bibliographic coupling, co-authorship networks, co-word mapping, etc. There are so many tools, qualitative tools can be applied for scientometric analysis that we are going to see as a practical manner in the forthcoming sessions. And these tools are very much useful for scientometricians mapping the parameters and accept for their study. And here I am going to categorize scientometric indicators, direct indicators and derived indicators. There are some direct indicators like total publication, number of words used, citation count, co-authorship, number of references. Derived indicators like highly cited papers. You can derive certain indicators like what are the highly cited paper, average citation paper, internationally collaborated papers, H index, G index, HG index, P index, like that. These are all derived, so that it's called as derived indicators. So some examples and formulas I have explained here. What is highly cited paper, how we are going to calculate average citation paper, internationally collaborated papers, like that. H index is the measurement to quality of the author can be measured by using different metrics called H index. G index in terms of quantity of the author can be measured. HG index is a combination of both quality as well as the quantity of the author can be measured. This is called HG index. And P index is the balance between the quantity and the quantity. That is called P index. So these are all different indicators which we are going to apply for our scientometric analysis. And I'm going to explore in a different way, like what are the other scientometric indicators can be applied for our research work, like document type of the published and cited document, author pattern and collaboration analysis of published and cited documents, geographical distribution of the publications, content-wise research output, and continent-wise, most productive countries, most productive journals, most productive institutions, ranking of most prolific authors, publication activity index, transformative activity index, relative specialization index, collaboration trend of the countries like authorship pattern and co-authorship pattern index, CAI, and relative growth index. Degree of collaboration, as you are very much aware, degree of collaboration of authors, whether single author or double author or multiple authors, and international collaborative share of collaborative authors, DCI, ICI, and affinity index, and indicators like international cooperation index. All these different kind of indicators can be applied in scientometric analysis. Like qualitative indicators, I just want to mention here something like year-wise published and cited papers with citation, authorship pattern versus citation score, and citation impact of scientific productivity, citation indicators of countries like research quality index, publication efficiency index, relation index, citation per paper, and attractive index. Highly cited publications and citation ranking of cited publications, most cited journals like for example for infertility and their impact. So correlation parameters can also be measured, which you are going to in the forthcoming session as like like correlation, number of contributors, citedness of publication, and authorship pattern, like our most productive journals, network analysis, for example, how which author is totally networked with other countries and other collaborations. All this kind of analysis can be used by using different kind of network tools also. How all these people are networked with each and everyone. We are going to apply several tools. So these are the different kind of qualitative indicators can be performed for scientometric analysis. For example, I have given certain tool like author map, bibcouple, site space, full text, and his set. Like there are so many other tools can also be applied for your scientometric analysis in the next sessions. These are different kind of analysis done by using scientometric tools. And importance and application is, if you want to know the grant and funding allocations, benchmarking activities, research priorities, scientific collaboration models, research ranking, policy decisions, science mapping, academic promotion, collection management, like all these levels which can be applied for scientometric analysis. And there are certain level of scientometric studies like micro level, meso level, and macro level. So in micro level, we can do it for individual or group. In meso level, we can do it for university, institution, and journals. Like macro level, it can be done for national and regional and global wise, it can be done. And types of scientometric indices like quantitative, qualitative, and both can be combined. Like as what I have mentioned earlier, there are different kinds of indices can be applied. So like H index, journal impact factor, JIF, how to calculate the journal impact factor for any journal. It's very easy way. Everyone can calculate in this way. And JCR is a journal citation report. It gives the overall citation value of each and every journal. It is done by Web of Science. Site score is again with the impact factor calculation methodology given by Elsevier. And SciMago journal ranking is another platform by Elsevier again. SciWorld is another product of Elsevier, which clearly gives overall collaboration and trends and reports about the particular field. Field weight citation impact is something different. Like in the particular field, what is the impact created by the particular author? That is also getting calculated by using this field weight citation impact. These are all very much valuable when we come across the scientometric analysis. And altmetrics are different kind of metrics apart from other classic metrics. So by using big data to measure the quality output in the web-based model. So another, that is alternative metrics can be applied by using different methodology. Like in social networking medium, what are all the reference managers who have used, and bookmarking tools, social bookmarking tools you have used. By using all these kind of social networking tools and Web 3.0 tools, we are able to retrieve the data and we can analyze the data by using the analysis. That is called altmetrics here. So like this we can mention. And there are some examples for bibliographic databases, which we are going to, in this session, we are going to explore, like, Web of Science and Scopus. We are going to explore in detail how to extract the data, how to retrieve the data, and in which format it can be extracted, and how it's going to be applied in the different kind of tools. That is also we are going to see in the forthcoming sessions. Above Science is Above Science, the core collection which I have explained: Science Citation Index, Social Science Citation Index, Arts and Science Citation Index, Emerging Source Citation Index, Conference Posting Citation Index. These are all the core collection of Above Science, and Scopus coverage is about like this. And here I just want to give more emphasis about the citation data. For example, I just want to give a Scopus as a citation database which covers about 16 million author profiles, 17 million items are available, and it helps the researchers to access the global research output, and to critical global research insights can be done, and which partner we need to collaborate, and to track the impact of research and monitor the global research trend, and to identify and analyze which journals to be read, for which we need to submit the article, whether it's having a proper citation or not. All this can be measured by using this tool now. So this is about the world of data which covers in Scopus, and it clearly gives the overall coverage about the Scopus and the representation of global discovery. And these are all the Scopus data model, for which we have around 70,000 author profiles from various affiliation. 70 million articles are available, 16 million author profiles are available. How many titles they have covered in site score. So what is the value it has? That is also mentioned here. Highest metric scores also can be calculated. They're using different kinds of metrics. So that kind of metrics can be analyzed by using Scopus data. And Plumx metrics they are using right now. So in Web 3.0, what are all the data which has been published in social media, that is also getting counted, that is also getting valued by visualization by using Plumx metrics. So this is about the basic introduction about scientometric indicators and citation databases. So in the next coming session, we are going to explore how to retrieve the data even for institution or even for a particular keyword by using Web of Science database and Scopus database, how it is going to be applied for our research output. So in the forthcoming session, we are going to explore this kind of videos here. So do a proper analysis by having a basic background of all these bibliometric and scientometric indicators. And with this thorough knowledge, please try to go to the next level of exporting data and how to apply different kind of scientometric and bibliometric tools for your analysis. Thank you.